Hey everyone! Today we are going to review about relations and functions. Now, a relation is a set of ordered pairs. What we have here right in front of us is an example of a relation. It's a set of ordered pairs, 1, 4, 2, 3, 3, 4, 4, 7, and 5, 8. Now, the set of first coordinates is what we call the domain. So in our case here, the domains consist of 1, 2, 3, 4, and 5. While the set of second coordinates is what we call the range. So in this case, it's 4, 3, 4, 7, and 8, which comprise the range. Now, we can write it this way. So the domain is 1, 2, 3, 4, and 5. While for the range, it is 3, 4, 7, and 8. Now, please take note that relations can also be written as a graph. Now, a function is a relation in which each element of the domain corresponds to exactly one element of the range. So, in our relation earlier, we can do a matching like this. 1 goes to 4, 2 goes to 3, 3 goes to 4, 4 goes to 7, and 5 goes to 8. Now, we know that this relation is a function because one element from the domain is matched to exactly one element of the range. So, our keyword here is that the element of the domain is only used once in matching. The value for the range can be used repeatedly. Like in this case, 4 has partners 1 and 3. So 1 is matched to 4 and 3 is matched to 4. So the range can be repeated, however, the domain cannot be repeated. Let's have some examples of functions. Our first one is a linear function. A function f is a linear function if f of x is equal to mx plus b, where m and b are real numbers. If we recall from our lesson in linear functions, m is the slope and b is the y-intercept. An example here would be this. F of x is equal to 3x plus 5. In this case, m is equal to 3 and b is equal to 5. And here's the graph of the linear function. Now take note that one element from the domain corresponds to one element of a range. For example, this -1 here corresponds to 2. So one of its ordered pair is -1, 2. And take note that the -1 is only used once, only at 2. Another example would be 0 and 5. So that's their pairing, 0 and 5. Another example is a quadratic function. Now, a quadratic function is an equation of the form f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. Now, the graph is a parabola. In this case, we have f of x is equal to x squared plus 2x plus 3. So a is 1, b is 2, and c is 3. Now, one of the fastest way to know whether a function is, an equation is a function or not is by using the vertical line test. So we do it by graphing the equation, then we draw a vertical line anywhere on the graph. Now, if a vertical line passes through the graph only once anywhere on the graph, then it is a function. If there's a vertical line which passes the function twice, then it is not a function. Another example is the constant function. Now, a linear function f is a constant function if f of x is equal to mx plus b, where m is equal to 0 and b is any real number. So in our example here, we have f of x is equal to 5. Now, m is equal to 0 here and b is equal to 5. So our graph here is a horizontal line. Next is the identity function. Now, a linear function f is an identity function if f of x is equal to mx plus b, where m is equal to 1 and b is equal to 0. There's only one example for the identity function, which is f of x is equal to x. In this case, m is 1 and b is 0. So as we can see here, the graph is a diagonal line. Another one is the absolute value function. The function f is an absolute value function if, for all real number x, f of x is equal to x if x is greater than or equal to 0, and negative x if x is less than 0. So it is commonly noted as absolute value of x. Like in our example here, f of x is equal to absolute value of x. So if x is positive, the y is positive. And if x is negative, the y would become positive. Lastly, we have the piecewise function. A piecewise function or a compound function is a function defined by multiple subfunctions, where each subfunction applies to a certain interval of the main function's domain. Basically, when we talk about piecewise functions, it is a combination of two or more functions, each working on a different interval. Like in this case, we have f of x is equal to 8 if x is less than or equal to 4, and 2x if x is greater than 4. Now, if our value for x is less than or equal to 4, then we're going to use the value 8 for our y. Like in our graph here, if x is 2, then y is 8. If x is 0, then y is 8, so on and so forth. But if x is greater than 4, we'll use 2x. So if x is 4, then y is 8. If x is 6, then y is 12 because it's 2 times 6, so on and so forth. So it is a combination of two or more functions. So that's everything about functions. I hope you learned a lot today, and thank you guys for watching.